All right, we're looking at solving logarithmic and exponential functions. But first, I wanted to show you how change of base works. So we're going to start with the function 2 to the x is equal to 4. And what you guys traditionally know is to snail or use Ben and Benny. So my base is log base 2 of 4 is equal to x. Okay, so just keep this in mind for a second. What the real thing to do when we solve for x is we are going to take the log of both sides. So I'm going to take the log of 2 and the log of 4. I'm going to use my power property to move the x to the front. So I get x log of 10 equal, log base 10 of 2 is equal to log base 10 of 4. Get x by itself by dividing both sides by log 2. Cancels, and I get x is equal to log of 4 over the log of 2. Change of base from yesterday, remember, says that you can choose any base you want. Log, so base 10, of the top number of 4 over log of 2. Magic. All right, moving on. So we're just going to go through these examples really quickly. So what would you do first here? I'm going to divide to get the exponent by itself. Okay, so 2 to the x is equal to 14. And then what you can do is you can snail or use Ben and Benny. So log base 2 of 14 is equal to x. Okay, the real way to do this is like this. 2 to the x is equal to 14. We are going to take the log of both sides. So I know that this is going to be x is equal to, x times log of 2 is equal to the log of 14 using my power property. Okay, divide by log 2, just like we did in change of base. So x is equal to log 14 over log 2. And we go ahead and divide that, and we get that is about equal to 3.81. This is my rounded answer. Log base 2 of 14, or log 14 over log 2 is my exact answer. Exact. All right, next, we're going to add 3 to both sides. And I get 4 e to the 2x is equal to 5. Go ahead and divide by 4. So e to the 2x is equal to 5 over 4. Leave it as a mixed number, please. I'm going to take the ln of both sides because ln e of e is equal to 1. And I'm going to move the 2 to the front. So I get 2x times ln e is equal to the ln of 5 over 4. Okay. ln of e is equal to 1, so it's just 2x is equal to the ln of 5 over 4. Finally, we're going to get x is equal to the ln of 5 over 4 divided by 2, all divided by 2. This is my exact answer. And this is about equal to positive 0.11, I believe. I'll just check it in my calculator. 1.2, 2.2. Oh, that's not right. ln of, this is equal to 0.091. Okay, I think I checked. All right, last one for exponentials, and then we're going to do some logarithmic functions. So solving with a quadratic looks really gross, but it's not as bad as you think. Okay, so I'm going to rewrite this. This is e to the x raised to the second power minus 3 times e to the x plus 2 is equal to 0. And I'm not keen on the e to the x as my base, so I'm going to replace it with u. So I'm going to let u equal e to the x. You need to write that if you replace a variable, okay? A number. So I get u squared minus 3 times u plus 2 is equal to 0. Anywhere there's an e to the x, I'm replacing it with a u. Next, we're going to factor. I get u minus 2 times u minus 1 is equal to 0. Now I'm just going to go ahead and replace this u back with e to the x. Minus 2 is equal to 0. And e to the x minus 1 is equal to 0. So we're going to use our zero product property. So I get e to the x equals 2. And e to the x is equal to 1. Next, we are going to solve for x. So you can either snail or you can ln both sides. The ln of e times the equals the ln of 2. So bring the x to the front. I get x is equal to, keep doing that, x times the ln of e is equal to the ln of 2. ln of e is equal to 1. So I get x is equal to the ln of 2, which is about equal to 0.69. 693. All right, lastly, we get e to the x is equal to 1. Ooh, this one's easy. Okay, so power property, x times ln of x is equal to the ln of 1. Sorry, x times the ln of e. E is equal to 1. So x is equal to, okay, what is e to the what power gives you 1? E to the 0 power. So I have two answers, 0 and ln of 2, or 0.693. All right, we're going on to logarithmic functions solving. Okay, so we're going to solve for the variable. We're going to write in exact form and as a decimal. You will have to do both on the test. All right. From yesterday, remember we have a property called the one-to-one property that says if we have the same base, so we're taking the same log, okay, then all we're trying to do is match our inputs. So this is the one-to-one property, okay? I get 5x minus 1 is equal to x plus 7. Subtract x. Negative 4, positive 4, I'm going to add 1, is equal to 8. So x is equal to 2. All right, we can always plug it back in to double check. So to check, I'm just going to be like log base 3 of 5 times 2 minus 1. 5 times 2 minus 1 is equal to 9. So log base 3 of 9 is equal to the log base 3 of 2 plus 7, which is equal to log base 3 of 9. All right, so it verifies. The second one here, we're going to do, let's get the ln. Our goal is to get ln by itself. So subtract 5. You get 2 ln of x is equal to negative 1. Divide by 2. So the ln of x is equal to negative 1/2. Then I am going to snail, basically. Okay, so I get e to the negative 1/2 is equal to x. And I type that into this is my exact value. As a decimal equivalent, that's equal to 0.607. Okay, so both of those. All right, get ln, your log or your ln by itself. So I'm going to divide by 2. I get log base 5 of 3x is equal to 2. And again, we're going to change this into exponential form. So 5 squared is equal to 3x. This is my base, my exponent, my number. Cool. All right. So 5 squared is 25 is equal to 3x. And then I divide by 3. So I get x is equal to 25 over 3. Or as a decimal, that would be, this is actually an exact value, 8.3 bar. Exact values are better than rounded numbers. All right, next, our ln is already by itself. So we can go ahead and just rearrange this. This is e to the 8 is equal to our input, which is x squared plus 1. Next, we're going to subtract 1. I'm going to switch these around. X squared is equal to e to the 8 minus 1. We're going to go ahead and square root. X is equal to the plus or minus the square root of e to the 8 minus 1. That's our exact value. And as a decimal, we get plus or minus 54.589. Okay. Last one. Okay, first we're going to use the product property to combine. So, and in fact, we're also going to use the power property. So product on this side and power on this side. So I get the ln of x minus 2 times 2x minus 3, is equal to the ln of x squared. You're like, this is really gross, but it's not as bad as you think, because remember that property from yesterday that talks about, like, if I have equal ln's on logs on both sides, all we're trying to do is match the input. This is called the one-to-one property. Okay, so we're going to use 1 to 1. Okay, so I'm going to go ahead and multiply these out. That's 2x squared minus 3x minus 4x plus 6 is equal to x squared, which is 2x squared minus 7x plus 6 is equal to x squared. Let's subtract x squared to get a 0. So I get x squared minus 7x plus 6. We factor that, which gives us x minus 6 times x minus 1 is equal to 0. So using my 0 product property, x minus 6 can equal 0, or x minus 1 can equal 0. So x can equal 6, or x can equal 1. And at first, you're like, okay, this is what I think it is, but we have to be really careful here because we get extraneous solutions a lot when we have powers. So and quadratic, so with exponential functions, or logarithmic functions. So we're going to plug them back in to check. So first, for x is equal to 6, we're going to have ln of 6 minus 2 plus the ln of 2 times 6 minus 3 is equal to 2 times the ln of 6. Okay, so we get the ln of 4 plus 12 minus 3 is 9 is equal to 2 times the ln of 6. So product property here, we're going to do ln of 4 times 9 is the ln of 6 squared. So that's the ln of 36 is equal to the ln of 36. At any point, are there any negatives as the input for the log? Let's see. So we're going to look. That was a positive, positive, positive. So we're good here. I can actually take the log of every single one of these numbers. So nope, your answer. So your solution works. We're going to do the same thing again, but with x is equal to 1. All right, so the ln of 1 minus 2 plus the ln of 2 times 1 minus 3 is equal to 2 times the ln of 1. All right, so I get ln of negative 1 plus the ln of negative 1 is equal to the ln of 1 squared. And I see right now, can you take the ln of a negative number? Okay, so I have negative, negative 1 is not in our domain. Remember, the domain for ln of x is x has to be greater than 0. So x equals 1 is an extraneous solution. I probably said that weird. Okay, thanks for staying with me today, guys. Bye. Oh, so what's your answer? My answer is only, so this is an extraneous solution. So my answer is only x equals 6. Okay, now thanks for staying with me. Bye.